I'm Tom MacWright, and this is kind of amazing that we have a talk about documentation right after testing. These are like the two things that nobody wants to do. So good, this is a real sign of maturity. And so on top of documentation, I'm also going to be talking about like this kind of documentation that we haven't really been doing recently, and I'm trying to do that. And so recently I've been working on documentation.js on Fridays. The rest of the week I work on cartography software. But it sits in this kind of cool place in the structure of documentation. So what I think we as a JavaScript community currently operate on is a lot closer to the top of this spectrum, where a lot of times we'll write a little bit of documentation and enough to kind of raise buzz, but not very much concrete documentation, and not really stuff that informs how you actually use code. So what documentation.js does is that it transforms JavaScript code with JS.comments into beautiful HTML, JSON, and Markdown. HTML is like kind of beautiful. I don't know. I designed it, so it's not that great. So you may be familiar with JS.doc. It looks a lot like Java.doc, so you might have like kind of horrible flashbacks of the 90s. But it is both like a standard for how you document code and also a tool that you use to document code. And my interest in this project came out of my kind of love of the standard and not quite love of the tool. I think it's a really interesting, complete tool, but there's a lot of space for creativity. What it kind of comes out with is documentation like this. This is a little bit from MapBox's library for, as you would expect, maps. And this kind of informs how you would use a function. This is a function called fire, and it shows you the types of the arguments and whether the arguments are optional, what it returns. Sometimes it'll include an option. So this is kind of the closest level between documentation and code. And so, yeah, kind of as I was saying, documentation generators have fallen out of favor. And so if you ever read the Node.js documentation, for instance, it's managed as a big markdown file. If you read the documentation for segment, it's managed in Jekyll. People generally don't write documentation this way, and there are lots of kind of critiques of why this is a bad idea. That it's verbose, or that code is documentation. Hopefully I don't need to debunk the notion that code is documentation. And also, my least favorite is that JavaScript is ineffable. That like JavaScript, it has like a flexible type system, and thus we can't describe it. And also that a lot of places will require documentation, and when people are required to do things, it kind of becomes like, you know, that form that you have to fill out, so you just kind of sketch your name in. And so they write bad documentation. But I think JavaScript has changed a lot in the last 2 years. I've been working on JavaScript projects for quite a while, and this is probably the most interesting period because I think it's matured and we're kind of entering a new level of systems. And so basically this talk is going to be a little bit less about documentation.js and more about the really cool thing that's inside of it that I've been excited about. And so in order, abstract syntax trees, type systems, and small modules have all just been kind of groundbreaking developments in how we can write code. Also, I work on it just because nobody else loves it, and that it's like the absolute, you know, vanilla problem to work on. So it just has no domain. And abstract syntax trees are so cool. So if you aren't familiar with abstract syntax trees, they're kind of a hackable representation of parsed JavaScript. And so you feed JavaScript code in, and it gives you this object structure that tells you what the code is. So it can answer questions for you like, is this a function? It's popularly known as the middle step for Babel.js, which is a compiler from ES5 to ES6, or you know, ES6 to ES5, and ES7 to ES5, and anything to anything else. It's pretty amazing. But it's so much more than that. In the blog post where they announced Babel 6, they talked a lot about how it's kind of going to be the platform of JavaScript tooling in the future. That Babel will probably be the inside of, for instance, test coverage utilities, probably test runners themselves, documentation, transpilers. Everything will be built on abstract syntax trees, as it already is in browsers. And so why is this so cool? Let's start out with the verbosity problem. Here's documentation. So this is kind of annoying, right? Because you read this documentation and it says that you have a function that's called times2. It's a member of a class called myClass, and it takes a parameter of a number. And so right below this is that you see the code. So this comment goes above the code. And this code says exactly the same stuff. And so what abstract syntax trees do is that it lets JavaScript actually read itself. And so within that big blob of parsed abstract syntax trees, it says that this is a member of my class. So you can go into the documentation, remove that, because the computer knows. It'll also say that it's a function and that it's called times2. So we can infer that as well. That's pretty cool. Like, we've eliminated a lot of our documentation. All of a sudden, a computer is writing it for us because JavaScript has only in the last couple of years grown this amazing ability to parse and understand itself. But we can keep going. There's still a lot in this that we actually don't need to write. So if we keep going, we'll look at this function called myClass.times2, function A. And I'm not sure, are people familiar with Flow or TypeScript? So along with ES6 and ES7 and all of the various wheelies that we're adding on to JavaScript, TypeScript and Flow mean that the types of functions that your JavaScript interpreter has been kind of guessing / munging together to make work for quite a while now, you can actually write those explicitly. So if you have a function that takes a number, you can actually say that it takes a number, or that it returns a string. Which is amazing for a lot of different ways. Basically, you can run a checker over your code, and the checker will be able to tell if you're calling a function wrong. But also, it just adds this actual information about the code itself. And luckily, we can also read that. So you can get rid of the annotations in your documentation and just use the ones in your code. And so at the end of the day, you actually get to this point where your documentation is only saying the human stuff, which is what documentation should be. And there are also, I think there's also quite a bit of people who don't want to write this either. Because, if you're getting paid to make things work and documentation doesn't, then why do it? But at least in my personal experience, documentation is kind of like writing an artist statement where you've already done the thing and now you're trying to explain what it's trying to say. And you look at the two things next to each other. And a lot of times I'll write a function and try to write the documentation for it and realize that it's not a well-defined problem, or that it's not a well-implemented solution. That, for instance, the function is trying to serve too many different purposes, and instead of just being a number input, it also takes a string, and if it takes a string, it also returns a string. You kind of realize the error of your ways by trying to explain them. So documentation is kind of like the rubber ducky method. So type systems basically make JavaScript a little bit less ineffable. PSA on this topic, JavaScript is kind of getting there, but other languages have been here for so long. Lisp especially is a language which can really easily read itself in pretty amazing ways. And both Mary Rose Cook and David Nolan have written really great articles about the fact that Lisp code can read itself, generate documentation about itself, write tests about itself without any human intervention. Because it can just do this at runtime. It doesn't have to parse the code from a string into a big object. The code is data. They call that homoiconic languages. So let's say that verbosity is reduced. The other really amazing thing about abstract syntax trees is that they work on the way out. So Babel famously parses JavaScript into this big object, transforms the object, and turns it back into JavaScript, and you run that. You can do the same thing with other languages. And so within the core of documentation.js, it actually transforms this combination of JavaScript and comments into a new abstract syntax tree and turns that into Markdown. And so, like, we're doing all this stuff that, like, the one amazing thing is that it's this huge processor of, like, a piece of software, and it doesn't contain regular expressions. Like, this is just, you know, the holy grail for me, pretty much. And so when we encode to something like Markdown, we don't have to worry about the fact that, like, Markdown has very weird stringifying rules and we have to, like, eliminate line breaks somewhere. We're just actually making functional transformations from one language to the other. And so here is, for instance, how we encode, like, a Markdown strong. So we can do this in, like, a really similar way that you would do a DOM in React. So I also, like, since Babel and previously Esprit is unlocking all of this, we have to really recognize that, like, building on the shoulders of giants, they've also been building on the shoulders of other giants. So, like, Babel is kind of the latest edition, but a lot of this work, especially, previously, let's see, the Eloquent Guide to JavaScript was mentioned, and that was Mergen Haverbeck, I totally botched that name, who wrote Acorn, and has been doing stuff like this pretty much unpaid for years, which is amazing. Like, all of these tools are kind of in the same place of documentation.js, in which they're like there's such a broad application that no company actually wants to invest in them, which is, you know, kind of, it's ironic. Capitalism doesn't really work, but like, hey, yeah, but, like, all of these tools are basically kind of version 1 through 6 of how JavaScript reads itself, and we're finally there because of all of these projects that are kind of building on each other. So moving on. The other thing that I think informs documentation.js is that we've really moved towards modular code. We used to have these big projects that could have one standard for how they're documented, and now we have a lot of projects like Mercury, where it's a front-end framework, but actually it's 50 different modules. It's 50 different GitHub repos, 50 different readme.mds to read. And working on these is kind of exhausting, because, you know, you want to debug a function, but really it's defined somewhere else, and, like, the best that you can do is just, like, have 50 tabs open. And so this approach of just, like, writing more stuff in the README becomes more and more tiresome as you switch to a more modular system, because do-it-yourself documentation does not combine. It's not standardized. It can't really be combined with each other. And so, real talk, I always read the code. Like, I don't know about you, but, like, whenever I use a module off the NPM, I clone it and read the source before using it. And when anything goes wrong, I skip the README and read the code. This is just kind of, it's not a good situation. So embedded documentation, I think, could be the way forward. And it's also really powerful because, like, for the first time with ES6 modules, where we have a module system in JavaScript, we know where code comes from. And so it's not just this insane attaching things to module exports and then they suddenly somehow get where we want them to be. Like, it's actually a standardized system where you know where things are bound. And so this is, like, the saddest point, pretty much. Like, what if we had this, you know? Like, what if we had IntelliSense in 1994? Like, pre-monopoly Microsoft. And we aren't there yet, you know? Like, with all the hype of, like, 2015 JavaScript, we can't do that. Like, that's a bummer, right? You know, we should be able to have, like, writing software as a little bit more than just, like, using Vim and typing in strings and hoping it works. And, like, guilty, I use Vim. But still, like, so documentation gets us somewhat there. Like, it's able to crawl dependency trees, it's able to figure out where your code comes from, and it can document modular frameworks. So one of the actual uses that I had initially for it was this module called turf.js, where you install it, and all that's inside of it is 50 modules that do one function each. It's a little bit, you know, it's extreme as far as the small modules idealism. But it works. And what we started off with was like, oh, if you want to read the function documentation for one of these functions, you have to like find the GitHub page and read that GitHub page and just like hope that it's exported in the normal way. But with an actual standardized documentation system, we can actually have all of the docs in one place, and in one website, in one README, in one JSON file if we want. And we don't have to write them all in one place, which is amazing. Like, it just doesn't really make sense to have like a modular system if you don't have modular documentation, because either reading documentation is exhausting, or the documentation isn't modular and you actually have a lower rate of change. And so the craziest thing actually that came out of Turf was that since we had all of this machine-readable description of what all the functions took and what they did, we could auto-generate a command line client. So Turf CLI actually doesn't have any functional code inside of it. All it does is look at all the modules and look at all of their documentation strings and construct the argument parsing of a command line client for all of them on the fly. Of course, that's a little bit like, experimental, but it's super fun. Speaking of experimental stuff that isn't finished, the main thing that I think is the problem is that JavaScript doesn't really have documentation culture yet. I think we recently acquired testing culture mostly because of test badges. Like those little CI badges on GitHub repos are just such an amazing social stimulus that like if something doesn't have that, it's like buying a non-Energy Star air conditioner. And so like there really isn't this expectation, and there are like services that try to tell you whether something's documented or not, but it's kind of a bizarre problem to quantify. There's also this like really big gap. So testing tools, for instance, testing tools are so cool, right? Like everyone hated writing tests, so we wrote all of these really space-age JavaScript frameworks that all like you can get like test reporters that are the Nyan Cat, that are rainbow. You can have your test like turn on your lights or like make them all red when tests are failing. And like all of this is kind of just like the carrot at the end of the stick to like get people to do this relatively boring thing. But we don't really have that for documentation, which is why I think like having beautiful output from a documentation tool is useful in a way beyond just the fact that it's the consumer writing it. It's like, you have to have some pretty simple impetus to do this kind of thing. But there's also, there's a lot to do. I also don't want to give a talk about an open source project and be like, I wrote this. That's just the worst thing to do. So a lot of the hard work on documentation.js was actually written by John Fireball and Anand and Bo and a lot of other wonderful people. You can try it today. I haven't really given a very good product pitch of it because this is just the talk about what I'm interested in. But that's it. Thanks.